Good evening, everyone, and welcome to the virtual public informational meeting for the Connecticut Department of Transportation, project number 111-127, rehabilitation of bridge number 5350 on Bosworth Road in the town of Pomfret. Here are some helpful links to reach. Oh, sorry. Here's some links for project email, phone, and webpage. Next slide, please. Here are how to use captions and subtitles in Zoom. Just a brief overview. There's several languages available. As stated, this is a brief overview of the meeting. My name is Mark Burns. I'm the supervising engineer for the local bridge program in the Connecticut Department of Transportation. My contact information is on the slide. There's going to just be some general housekeeping, a formal presentation of the design, which will include explaining the purpose and need of the project, our proposed recommendations, and we'll follow with a live question and answer session through the Zoom. This is a slide regarding Title VI and civil rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out the voluntary post-meeting survey located at the link and QR code adjacent. There's also a link related to the civil rights information to the department's Office of Equity. Recording this presentation will also be posted to YouTube after the event, and closed captioning, including non-English translation options, are available on the Zoom and on YouTube. This is another slide regarding Title VI and civil rights. I won't read it, but it's here. And then in Spanish as well. Here's a brief overview on how to use the Zoom Q&A. On the bottom of your screen, you should see a Q&A button, and you can select it at the bottom, and then type your question right in there, and the panelists will be able to answer it for you. If you're an audio-only participant, please dial *9 to raise and lower your hand. You can also reach us by email at dot-flbp@ct.gov, by monitored voicemail line at 860-594-2020, and in the Zoom Q&A chat. Please keep in mind that the Zoom Q&A is only available during the live presentation. You can also visit the project webpage and submit comments. The comment period is open until July 9th, 2024. The funding for this project is through the Federal Local Bridge Program's Design Managed by State program. In the past, the program was funded on an 80-20 split, with the federal government or the department participating in 80% of project costs and 20% being the responsibility of the town. Under DMS, the design, rights-of-way, and construction phases are funded with a minimum of 80% federal dollars and a maximum of 20% state dollars. Design, rights-of-way, and construction phases are at zero cost to the town, and the department uses their consultant liaison, or CLE, engineers and our task-based designers to complete the design. Now, while the department is taking over the design on behalf of the town, it is still a full partnership and coordinated with the town, and we solicit comments and input from them at project milestones. The goal of the DMS was to provide a streamlined approach to design using our full DOT resources to aid towns to keep their bridges in a state of good repair, to decrease typical design time, and to utilize accelerated bridge construction techniques where applicable to shorten construction duration, and to increase the number of municipal projects delivered each construction season. As I say, my name is Mark Burns from the department. I'll introduce the rest of the project team from the Division of Bridges. Our division chief is Bart Sweeney. Our principal engineer is Derek Lassard. Jeff Organic is the project engineer. And from the department's Office of Rights-of-Way is Zach Areno. Representing CHA is Anand Sasadri, CLE team leader, and project engineer Rochelle Clark. This is a brief slide showing the key structural elements of a bridge. As you see on top, there's the deck, which is what the driving or traveling surface is. On top of the deck are parapets, which will act as a barrier from vehicles, pedestrians, cyclists, from any roadside hazards. Supporting the deck and parapet are the superstructure. In the case of this slide, it is steel beams. Supporting the beams and superstructure are the abutments, otherwise known as the substructure. The wing wall is used for earth retention. And then in some cases with a longer span, there will be a pier or multiple piers. Bridges are rated on a scale of 9 to 1, with 9 being in excellent condition and 1 being an imminent failure. But don't let that concern you, because at any point, the Office of Bridge Safety monitors our structures on a biennial basis. And if there's any concerns, they will alert the town to take any corrective action. This is a briefing. This is another elevation view of a similar structure. In this case, is a precast concrete rigid frame with similar elements. This is a slide on concrete deterioration and different types. Efflorescence on the top left corner is when there is a chemical reaction, which causes that white substance that you tend to see on concrete. Honeycombing is a situation where there's some air entrainment issues, which result in freeze thaw. Scaling is another result of freeze thaw and wear and tear that you'll sometimes see on a bare bridge deck. Map cracking is another example, with surface water when not causing cracking. And then spalling is a more serious condition in where the existing concrete reinforcement is exposed. I'll now turn over briefly to Maureen Nicholson for Selectman Town of Pomfret for some remarks. Maureen? I think Maureen might be on mute.
Hi, welcome. I want to thank Mark for this presentation and for the DOT for this project and CHA. This is a great program. It's very helpful for small communities like Pomfret that have a hard time coming up with a 20% match. And through this local federal bridge program, it's the 80% federal and the 20% state. It makes it possible for us to keep our bridges in good repair. And through this program, we are replacing this bridge and several other ones in town. And I think you'll find the presentation very interesting. Every time I listen to one of these, I learn something interesting, and I very much enjoy them. So let the good times roll.
Thank you, Maureen. I'll now turn over to Rochelle Clark from CHA for the formal presentation. Rochelle?
Thank you very much, Mark. As Mark said, I am Rochelle Clark, and I am the liaison engineer on the project. So I work with the DOT as well as the consulting engineer to oversee the project and pull all the different parts and pieces together. The bridge that we're going to be talking about tonight is Bosworth Road over Mashamoquet Brook. Bosworth Road, or this bridge, Bridge 5350, is located about 800 feet east of Killingly Road, which is also State Route 101. In this area, Mashamoquet Brook runs from north to south, and this area is fairly rural in nature. This bridge has 2 travel lanes. The roadway is approximately 18 feet wide, and the bridge sees about 79 vehicles per day, and that count was most recently taken in July of 2023. The speed limit for the roadway is 25 miles per hour. However, we did do recordings of the speed as well as the traffic counts, and we found that the 85th percentile speed is 34 miles per hour. And what that means is that 85% of people who cross the bridge are going 34 miles per hour or slower. Not surprisingly, because of the low average daily traffic or average daily vehicles, we have a classification of rural local road. This bridge was originally constructed in 1950, so it's about 73 years, which is getting close to the end of its service life. The bridge was rehabilitated in 2000. That was a superstructure replacement. So it replaced the top portion of the bridge, but kept the original substructure. This bridge is a single span, which means that it doesn't have any additional piers in the water. The bridge length is 28 feet 7 inches, and that is our span length, which is slightly different from our clear span. So the clear span on this bridge is actually 26 feet, and we measure that clear span from inside face to inside face of the abutments. As Mark mentioned, going through the different components of the bridge, starting at the top, we have bituminous concrete, which is our wearing surface, on top of corrugated metal deck. That corrugated metal deck is in turn supported by steel beams. This particular bridge actually has galvanized steel beams, which is why it's that gray color. And those beams are supported by the abutments. And those are the concrete structures that you see on each end of the bridge. This bridge does have scour walls, so you'll see a small bump out of concrete in front of the abutment, and those scour walls are meant to protect the bridge from scour. And basically, scour is when material moves away from the bridge structure and can cause undermining, where you get pockets of voids underneath the substructure. The substructure rests on footings, and those footings in turn are bearing on soil. The footings are below water, so we can't see them in this photograph, although we do have some photographs later to show you a little bit more of what those scour walls look like. For this bridge, our approximate 100-year storm elevation, as you can see, is close to our roadway elevation. So for our 100-year storm, our water surface is pretty high. As I mentioned, we do have a 26-foot clear span, and that is less than 54 feet, which is 1.2 times the bank full width. So one of the things that we look at in the hydraulics is we look at, well, how wide is the river in this area? And so one of the measures of that is bank full width. And essentially that's basically, kind of top of bank to top of bank. And for this particular bridge, that width is about 45 feet. As general practice, we like to see bridges that are 1.2 times that, so slightly wider than our bank full width. And in this case, our existing bridge is at 26 feet. So what that means is that the river has to neck down quite a bit in order to get through this structure. This bridge does not have any underclearance. And what that means is from the bottom of our structure to the 100-year storm elevation, there's no additional room underneath the bridge for debris to flow underneath the bridge. So because the 100-year storm elevation is so high, we do not have any underclearance on this bridge. Freeboard takes a look at the low point of the roadway compared to the 100-year storm elevation. And in this case, as in the case of a lot of bridges, the low point of the roadway is actually not on the bridge. So in this particular case, it's west of the bridge, and the water does overtop the roadway for that 100-year storm. So, if one of the minimum standards that the department has is, we like to meet 1 foot above that 100-year storm for the low point of the roadway. Because this is overtopped, our freeboard is basically 0. Another thing that we look at is, when water has to move through the bridge, it backs up a little bit. And so we look at, well, how much does the water back up compared to if the bridge wasn't there? So for this particular bridge, our backwater elevation compared to natural conditions is 1.7 feet. Generally, when we're looking at bridges, we like to look at a standard of having that be about a 1 foot maximum. In terms of scour for this bridge is considered scour critical. And currently we do have, some undermining of the structure, and that is both underneath the scour walls as well as the abutment stems. And it's not all the way across the bridge, it's sort of in pockets, but there are some voids underneath the substructure where some of that material has been washed away. As Mark mentioned before, bridges are rated on a scale of 1 to 9. So we're going to look at those for this particular bridge. For our deck, we have a satisfactory rating of 7. So the deck is in good shape. The approach is is good. Our approach is satisfactory at a 6. Our superstructure, not surprisingly, because there was a superstructure replacement in 2000, is also in good condition and rated a 7. Where we start to see some of our lower ratings is when we start looking at the substructure. Again, that substructure was originally built in 1950. So right now the substructure is rated poor, and that's rated poor both for the condition of the substructure, kind of deterioration in the concrete that we're seeing, as well as the fact that we do have that undermining that's been shown to be at the scour walls and underneath the abutment stems. Last, we have a channel and channel protection, and those are kind of up and downstream of the bridge. However, in this particular report, the channel and channel protection were downgraded a little bit because of the undermining of the bridge. But up and downstream, the channel and the channel protection are in pretty good shape. It's just right at the bridge where we're seeing scour issues getting a lower rating. Another thing to note is that despite the fact that the railing and the approach guide rail are rated a 7, which means that they're in good condition, these do not meet current safety standards. So these elements are substandard. We have some photos of the site to share with you. Our first photo in the top left is the south elevation of the bridge. This is the outlet of the bridge. In the top right, we have the north elevation of the bridge. This is the inlet side. The bottom left photo is Bosworth Road looking east over the bridge. As you can see, the elevation goes up as you move further east. The next photo, the bottom right photo, is Bosworth Road looking west over over the bridge. And as you'll note, the elevation tends to go down on the west side of the bridge, and this is where that low point of the roadway is and where the road overtops during the 100-year storm. And our next set of slides at the top left slide is Bosworth Road looking east. One of the things to note in this slide is that there is a driveway that is relatively close to the project site. This is a residential driveway northeast of the bridge. The top right photo is Bosworth Road looking west. Again, we're pointing out a driveway. This is actually an unpaved driveway that acts as a field access. The bottom left photo is a picture of the northern bridge rail. The southern bridge rail is very similar. Again, and we're just noting that this is a substandard bridge rail. In the bottom right photo, a couple things to note here. The first is that we have a utility pole as well as some overhead utilities. And we also, this photo also kind of shows the condition of the pavement in the area. It's not in terrible shape, but there obviously has been some maintenance done to it and some patching. The top left photo in this next set of photos is a typical underside of the bridge. And again, these are rolled steel beams, and that gray color is because they are galvanized. The top right photo is the bridge rail attachment, and here you can see that that bridge rail cantilevers off of the fascia beam. The bottom left photo is the east abutment. Again, you can see the flat face of the abutment here, and this portion here where there's sort of a bump out, that's actually the scour wall. And that scour wall just sits out in front of the abutment, and the purpose of that is to protect the foundations from scour. The bottom right photo is the west abutment, and just very similar to the east abutment, we have a scour wall in front of the abutments. The top left photo in this next set of slides is a photo of the northeast wing wall. You'll notice that unlike the abutments, this is actually constructed of masonry. So this is a masonry wing wall that has some areas of deterioration, and you can see there's some efflorescence, this white staining that just indicates that moisture is moving through this wall. The top right photo is the northwest wing wall. This is very similar in that it's a masonry wing wall, and we can see areas where there's masonry missing. Looking at the bottom left photo, this is one of the more significant photos that we have to share with you. This is our typical undermining at scour walls. This photo was taken from the underwater inspection report. And as you can see, the tape measure here actually extends below the footing or the scour wall, showing that this is actually, we've lost material there and there's some undermining. In the bottom left, we have a photo of the south embankment. This is just to demonstrate that we have some steep embankments in this area, and in this particular case, it's needed to reinforcement using some large boulders to prevent erosion. Our last two photos are the upstream channel. This is looking to the north. And our top right photo is the downstream channel looking to the south. And as I spoke about before, our bank full width here is quite a bit wider than our bridge. Our bank full width is about 45 feet compared to our 26-foot clear span. So the project purpose and needs include addressing the poor condition of the substructure. We do have some of those things that Mark mentioned, where we have, areas of spalls where the concrete has deteriorated. We also want to eliminate the scour critical condition. So we want to address the fact that we have a bridge where we're seeing that material move away from the foundations. We also want to replace the bridge and approach rail systems so that they meet current safety standards. And we want to improve the hydraulic adequacy and performance of this bridge. And at the end of this project, we want to have a bridge that has a 75-year service life. So what we're proposing for this project is a full bridge replacement. One of the things that we do want to know is that despite the deficiencies that we've discussed, that the bridge is safe for the traveling public and is inspected regularly by Connecticut DOT. So the proposed replacement bridge is a new pre-stressed concrete adjacent deck unit bridge. And we'll get into what those adjacent deck units look like in a future slide. This bridge will provide a 75-year service life with minimal maintenance. It will carry AASHTO design, legal, and permit vehicles. So there will be no weight restrictions on the bridge. There will be a pile foundation designed for scour. It will have an open bridge rail and approach rail system meeting current standards, and will also be improving the roadway to make it 24 feet wide. In terms of our improved hydraulic performance, we are going to be widening the bridge, making it longer. So right now, we have a 26-foot clear span. We'll be going to a 40-foot clear span. Our structural span's a little bit longer than that. So from support to support, it's 43 feet. We're also raising the bridge to be about a foot higher than it is currently. One of the things that this will do for us is that for the 10-year storm, which is a more frequent storm than our 100-year storm, there will be increased underclearance. And again, that's just the space between the bottom of the bridge and the water surface that allows debris to pass. So we'll be going from 0.4 feet of underclearance to 1 foot of underclearance. Our approach roadway, right now, the frequency for overtopping is that roadway will overtop for a 25-year storm. With the new bridge, that is improved so that the roadway will be overtop for storms 25 years and greater. So again, less frequent storms, less frequent overtopping of the roadway. We'll be reducing the backwater elevation marginally from 1.7 feet to 1.6 feet compared to the natural conditions. And the bridge roadway will be overtopped, it will still be overtopped for the 100-year storm, but the bridge will be functional and stable even in those large storms. We'll also be improving the aesthetics of the bridge. So one thing that we will have is a stone veneer or a simulated stone veneer. So that's accomplished with form liners. So the concrete will look like stone and be stained to look like stone. And the open bridge rail will be metallized to a choice of the color of the town's choice. So here is a cross section of our bridge. So if you were to take the bridge and kind of just take a slice through it like it was a piece of cake, this is what you would see on the inside. And this is where we can see what those adjacent deck units look like. So starting from the top, the bridge will be 27 feet, 6 inches out to out. That provides for a 24 width roadway that's comprised of two 12-foot lanes. On each side, we'll have our 3-tube open bridge rail that will sit on top of a concrete curb. The roadway will have 3 inches of bituminous concrete over a minimum 6-inch topping slab. You can see that the roadway is pitched to drain on each side. And then all of that will be supported on our pre-stressed concrete adjacent deck units. And that's what these elements are below the roadway. In terms of our bridge layout, again, we have a 43-foot structural span from support to support, which gives us a 43-foot clear span from inside face of abutment wall to inside face of abutment wall. In this plan view, orange is the superstructure, gray is our substructure, and as you can see, we have U-shaped wing walls on each side. The roadway is in yellow, so yellow indicates areas of full depth reconstruction. The waterway is blue, and again, this river flows from north to south in this area. The purple areas are wetland areas. Areas of green are areas of fill, and those are areas where we're actually adding material in order to raise the roadway up. You can also note that we have the field access over here in brown. Our new approach rails are in pink. We'll get into the rights-of-way lines in a future slide, but these dashed lines indicate different lines related to rights-of-way and property lines. The last thing you'll note is that we have these areas of blue, and these areas of blue are actually places where we are reinforcing the embankments with riprap. So knowing that this bridge is going to overtop for the 100-year storm means that we're going to put some riprap in here to prevent that those areas from eroding from overtopping of the bridge. This is an elevation view of the bridge. And here again, you can see our superstructure is in orange, our substructure is in gray, our water here is in blue, and our approach rails are in pink. And the thing to note about this particular slide is that our foundations are actually supported on piles, and those piles go all the way down to bedrock. And that's what provides the stability for this foundation system during those larger storms and eliminates the scour critical condition of this bridge. So essentially, if you had a really, really large storm and material were to wash away below the foundations, all of these piles here will still support the bridge, and you don't have to worry about the stability of the bridge. This is a slide showing our proposed roadway plan. Similar to our previous slide, blue indicates water for the Mashamoquet Brook. Yellow are the extents of the full depth reconstruction, and those extend about 85 or 800 feet within the project limits. Another thing to note about this is that we do have a small area here that is actually a pull-off area. So one of the things that we were requested to provide by CTD Fisheries was a pull-off area for anglers who want to fish in the Mashamoquet Brook. So it's been included here. You can also see the areas of blue riprap, and you can see that they do extend pretty far, and they're primarily on the downstream side of the bridge. And the reason is because as the water comes up, it's not moving very quickly on the north side of the roadway, but as soon as it crosses over the roadway, it picks up speed. That's why we need additional riprap on the south side compared to the north side of the bridge. And this is a picture of our proposed roadway profile. One of the things you'll note about this is that there's a large area of green, and that's just indicating where we are raising the roadway. And this is the slide where I kind of want to talk a little bit more about freeboard and a couple of other things. So, I had mentioned before that when we measure freeboard, we measure it to the low point of the roadway. And so here you can very clearly see that the low point of our roadway is here on the west side of the bridge. So this is where the water overtops. We spent some time when we first started working on the design of this bridge, looking at, what kind of a bridge do we want to replace it with? And so our first goal was to try to meet that 1.2 times bank full width. And what that did was it gave us a bridge that was about 54 feet clear. And essentially what happened is then this roadway slope came and cut into this downward curve on the west side of the bridge. So with that 54-foot span, we were able to pass the river without it overtopping the roadway, but the consequence of that was a lot of additional water built up on the backside of the bridge. And when that happens, and when the backwater increases in elevation, it overflows onto adjacent properties and causes flooding on properties where there wasn't previously flooding. It was determined that in order to have a bridge that would meet that criteria, the bridge would need to be in excess of 90 feet long. And for this particular site, a 90-foot long bridge was just really an excessively long bridge for a local road. So what was determined was to do what we could to improve the hydraulics, reduce the frequency of overtopping of the roadway, but to and make those improvements, but without putting in an extremely long 90-foot bridge. And so it was found that this 40-foot clear span was the best option to balance the need to improve the hydraulics without, creating excessive backwater. This is our temporary roadway and utility impacts. So there are several residential homes on the east side of this bridge on a dead-end road, and so we need to maintain access for them as well as power and communications. So we are proposing a temporary bridge on the south side of the existing bridge. The reason the south side was chosen is because there's a small unnamed brook that joins the Mashamoquet Brook on the north side of the bridge, so we would have needed a significantly longer temporary bridge if it had been located on the north side. The advantage is that we have a shorter bridge. The disadvantage is that there are overhead utilities in the way. So we will need to temporarily move the overhead utilities to the north side of the bridge, and those will be out of the way during construction, and then they will be moved back for their final location. This bridge is about 65 feet long, and it will be about 14 feet wide, and that should be, wide enough that it will accommodate the town's emergency vehicles, so that will not be an issue for the residences beyond. It will be stoplight controlled, one-way alternating, so the cars will take turns going over the bridge, and it will be controlled by stoplights with detectors. This is our temporary roadway profile. One of the things that this is showing is these areas of green indicate that there's a significant amount of fill that needs to be put in order to create that temporary roadway. That will be removed and the area will be restored to the way it was once the temporary bridge is taken out and the project is complete. In terms of environmental impacts, we are expecting to have temporary and permanent wetland impacts. There will be tree clearing along the roadway, and there are several species in the area that will require best management practices by the contractor. One of the species of concerns that was identified is the wood turtle. So there will be best management practices included in the contract. For example, the contractor will not be allowed to dig into the soil until a specific time in the spring after the wood turtles have emerged from hibernation. So they won't be disturbed by any of the digging that the contractor does. Again, I mentioned before that there is a pull-off area of anglers included in the project, and that was, again, something that was included at the request of CT Deep Fisheries. We have environmental permits that are required for the construction of this project. They include the Town of Pomfret Inland Wetlands Permit, a CTD Flood Management Certification, as well as a U.S. Army Corps pre-construction notification. This area around Mashamoquet Brook is archaeologically sensitive, and because of that, a phase 1 survey has been initiated, and that's currently underway. So any findings from that will be included in the final design of the project, any impacts from that survey and that study of the area. In terms of rights-of-way impacts, there are going to be rights-of-way impacts for construction of this project. The first one is that we are going to need a small property acquisition that small acquisition will allow the contractor to install the new abutment footings, and then it will also allow the town to access the foundations for future maintenance. Another area that's going to be impacted is an easement will be required for the installation and maintenance of the guide rail. The end of the guide rail is located this or at the northeast side of the bridge. The end of the guide rail, it does cross over that right-of-way line, so an easement will be needed for that. We're also going to need um, slope easements. So because we're raising the roadway and we are increasing the amount of fill, that has to be sloped. So easements for the embankment of the roadway are going to be required. Finally, we have these areas that are in purple. Those areas are construction easements, and those are needed for the temporary roadway as well as the relocation of the utility lines temporarily on the north side of the bridge. There are other rights associated with this project. There will be rights to grade driveways. There will be rights to reconstruct driveways, rights to grade associated with the reconstruction of those driveways, as well as rights to install sedimentation and erosion control. And at this time, I'm going to turn the presentation over to Zach, who's going to talk a little bit about the Division of Rights of Way.
Thanks, Rochelle. My name is Zachary Garino, and I'm a project coordinator with the Department's Division of Rights of Way. Our office is responsible for acquiring the property rights needed for transportation projects. As mentioned in the presentation, this project will require the acquisition of property rights, so I'd like to give a brief overview of our acquisition process. Before I begin, I'd like to mention that the specific impacts are still being finalized and they may change as the design progresses, and that any required property rights will be acquired in accordance with Connecticut General Statutes, Sections 13A 73 and 13A 98E, as well as the Uniform Act. Change the slide. So the right-of-way process begins once the design has progressed to a development milestone and all of the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map which depicts the exact property rights to be acquired. Now on the screen here is an example of a property map that an owner may receive. It shows the existing conditions as well as the proposed, and that would be specific to each property owner. Next, our office will determine the fair market value of those property rights which were depicted on that map, and that'll be used to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impacts to their property, and explain how the state arrived at its offer. The property owner will be given a reasonable amount of time, typically 30 days, to consider the state's offer and enter into negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town land records. However, if agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. And it's important to note that the state only acquires property rights that are needed for the specific project. If there are any questions regarding the right-of-way acquisition process, I can answer them after the presentation. With that, I'll hand it back to Rochelle. Thank you.
Thank you, Zach. In terms of our project cost and schedule, the construction for this project is anticipated to start in the spring of 2027. It is anticipated to last 2 construction seasons or 16 months. So those are time periods during the summer when the contractor can do work with a winter shutdown during those 2 construction seasons. The construction cost for this project is estimated to be $3.47 million. And again, this is, as Mark mentioned before, the funding for this project is 80% federal funds and 20% state funds. So this project is being done at no cost to the town. We do note that the cost and the schedule are subject to change. And at this point, I will turn it back over to Mark for our Q&A session.
Thank you, Rochelle. Thank you, Zach. We're putting up the slide now on ways to reach out to us either by email, phone, or in the live Q&A chat. If you have any comments, you can put them in the chat today, or if something comes to your mind later. Our comment period is open until July 9th, 2024.
I guess I'll ask a question, if that's all right. It's Maureen Nicholson.
Absolutely. Yeah.
So, I'm curious what happens to all of the material there, that the existing abutments, all of that gets pulled out and taken away?
Or Rochelle, do you want to take that question?
Yeah, correct. So all of the abutments will be taken out. So the substructure will be fully removed and disposed of, and the same with the roadway material. So that is considered, waste material. So it's, taken to the right types of facilities and disposed of properly.
Thank you.
We have a question from Bob Hanley. If you raise Bosworth Road entrance height, will it act more like a dam and flood the property nearby? Rochelle, is Scott still available? You can maybe answer that question.
Yeah, Scott or Olin, would either of you like to take that question?
Yeah, I can take that question, I guess. So if basically our hydraulic analysis indicated that raising the roadway profile, as Rochelle kind of indicated with her presentation, did result in adverse impacts to the adjacent properties if there wasn't a sufficiently large, or in this case, a significantly larger, greater than 90-foot bridge at this location. So that's why whenever there's overtopping of that roadway within that low point of the roadway, there's a balancing act essentially to improve hydraulics while still not causing adverse flood impacts.
So if I could add to that, essentially the road is being raised, but the bridge is also being made wider, which does allow the passage of more water. And one of the criteria that we look at is what is that surface elevation of the backwater. And so currently, right now, for a 100-year storm, that backwater elevation is 1.7 feet. So with our new bridge, that's actually going down to 1.6 feet. So the to, I guess to further answer the question, the way the bridge is being designed currently, the proposed bridge, you will not see it acting like a dam and creating, flooding on the backside. If we were to go with a 54-foot bridge, it shifts the low point and it prevents water from going over the roadway. And so that's where you start to see issues with it building up on the backside and creating flooding.
Great. Thank you. We're going to keep the live Q&A open for a few more minutes. If you have any other questions, please feel free to ask. Okay, not seeing any questions coming through. I think we can wrap up this presentation and Q&A. Again, thank you for attending. And if you have any questions beyond tonight, you can email us or go to the project webpage and submit a question. Thank you.
Great, thank you.
Good night, everyone.
Thank-